Good day, we have this topic for today, useful theorems and rule of signs under polynomials. Welcome to my tutorial. We have the following objectives. Number 1, recall how to find the roots and factors of the given polynomial using rational root theorem and determine the number of positive and negative real roots of the given polynomial. Don't forget the following. RRT or rational root theorem only gives the rational roots of the polynomial. So it does not give all the actual roots of the polynomial. That's why for today, we're going to study or discuss that some roots may be irrational or imaginary. The fundamental theorem of algebra states that any polynomial of degree n has n roots, but we may need to use complex numbers. So meaning to say, without actually solving, we can determine the number of roots by simply looking at the degree of the polynomial. But still, complex numbers are included here. It is possible that we need to use complex numbers to make the polynomial equal to 0. So looking at the illustration here, a complex number is a combination of real number and imaginary number. So this is the real part and this one is the imaginary part or the complex number. So take note that when you see square root of -1, its equivalent is equal to I, which means imaginary. In the illustration here, it explains that complex roots always come in pairs. So they are always partner. So looking at here, one is positive, the other is negative. So the pair is actually complex conjugates, where we change the sign in the middle like this one. So positive, negative. So they always come in pairs and they are always complex conjugates. This diagram or illustration will help us as our guide for us to determine the number of complex roots. So if the degree is 1, the possibility is there's one root, one real root. If the degree is 2, there are 2 possible roots, 2 real roots, or 2 complex roots. If the exponent or the degree is 3, then there will be 3 real roots or 1 real and 2 complex roots. If there are 4 degree or the degree is 4, there will be 4 possible roots or roots. For all the 4, may be real roots or 2 real and 2 complex roots or 4 complex roots. So we either get no complex roots, 2 complex roots, 4 complex roots, and so on and so forth, and never 1, 3, 5, and all odd numbers, because it was stated earlier that complex roots should come in pair, so the number of roots should be even number only. Next, let's have the rule of signs. It is a special way of telling how many positive and negative roots a polynomial has. Sometimes we may not know what the roots are, where the roots are, but we can say how many are positive or negative. And that is by simply counting how many times the sign changes from plus to minus or minus to plus. Example number 1, how many of the roots are positive? And this is the rule. The number of positive real roots of a polynomial equation p of x is equal to 0 with real coefficients equals the number of sign changes, or a value less than that by some multiple of 2. Before we actually apply or count the number of sign that change, let us first see to it that the given is arranged in standard form. Meaning to say, all the degrees or all the exponents should be in order from highest to lowest. Now, in this case, it's not arranged, so let's arrange it first. So we have negative 3x to the fifth first, followed by x squared, then plus 4x minus 2 is equal to 0. And then, let's count the number of change. So from negative here to positive, so there is change. So there's one change. From positive to positive, no change. From positive to negative, there is change. So this is the second change. Therefore, we are expecting two positive roots in this polynomial. So two positive roots in this given polynomial. This time, let's have example number 2. This is now asking how many of the roots are negative. The given is the same as the previous one, but this time we have to look for the number of negative roots. Before counting how many changes here, we have to change first x into negative. So this is how it is. Copy negative 3, then x here will become negative x raised to 5 plus negative x squared plus 4 times negative x minus 2. Then let's simplify. If negative x here is raised to the fifth power, it's still negative times negative outside. So this will be positive 3x to the fifth. The negative x squared is positive times positive, positive x squared. Positive 4 times negative x is negative 4x, then copy minus 2. Then let's count the changes. So from here, it's positive to positive, no change. Positive to negative, one change. Negative to negative, no change. Therefore, there is one negative root. One negative root. Next. Example number 3, 2x to the fourth minus 5x cubed minus 4x squared plus 10x minus 3 is equal to 0. How many roots are positive and negative? Let's do first the number of positive. Let's count. It's positive here, positive to negative, there's one change. Negative to negative, no change. Negative to positive, second change. Positive to negative, third change. We are expecting 3 positive roots. Next, what about the negative roots? Let's change first the values of x to negative. So, let's do it. If x here is negative, negative to the fourth power is positive. Times positive outside, still positive. So 2x to the fourth remains 2x to the fourth, positive 2x to the fourth. Next, if x cubed is negative, negative to the third power is negative times negative outside is positive. So positive 5x cubed. Here, if x is negative, then negative squared is positive times negative outside. So negative 4x squared. And if x here is negative, it's negative times positive 10. So negative 10x. Then simply copy minus 3 is equal to 0. Then let's count the number of change. Positive to positive, no change. Positive to negative, there is change. Negative to negative, no change. Negative to negative, no change again. So we are expecting one negative root. So these are the answers to the question, how many of the roots are positive? So there are 3 roots. How many of the roots are negative? There is 1 root. Example number 4, x cubed plus 3x squared minus 14x minus 20 is equal to 0. Here we have to find the roots. Let's apply now the rational root theorem by looking at the constant term and the coefficient beside the leading term, which is 1 here. So negative 20, we have to get the factors. Let's line up the factors. What are the possible factors? Since this is 1, automatic that our factors will be coming from the constant term here. So we have positive negative 1, positive negative 2, positive negative 4, positive negative 5, positive negative 10, and positive negative 20. So there's a lot. We are expecting 3 roots because the exponent here is 3. So we are expecting 3. It's 3 real roots, or there's a possibility that we have 1 real root and 2 complex. Remember, complex numbers should come in pair. That's why it's possible that we have 2 complex here and 1 real root. It's trial and error here, unless you want to try it all, but it will take time for you to do that. Now, let me jump to positive negative 5. First, let me use 5 as my divisor for me to find out whether this one is a root. So 5, and then let me write all the coefficients here. So we have 1, 3, negative 14, negative 20. Bring down 1. 1 times 5 is 5. 3 plus 5 is 8. 8 times 5 is 40. Negative 14 plus 40 is 26 times 5. Obviously, will not give us positive 20. So 5 is not a root. Now, let me change it to negative. Then let me erase all this. And then try again if negative 5 will be a root. Okay. Bring down 1. 1 times negative 5 is negative 5. 3 minus 5 is negative 2. Negative 2 times negative 5 is positive 10. Negative 14 plus 10 is negative 4 times negative 5, positive 20. Finally, we got it. Therefore, negative 5 is a root. So, it's a root. Now, we're looking for 2 more, but the first equation can help us. Let's change this to the first equation. This is the same as x squared. Remember, this is 3, so minus 2. That's why it becomes 2 here. Minus 2x minus 4. From here, let us factor this out for us to come up with other roots. Can we factor this? Negative 4. Think of factors that will give us negative 4, and when we add or subtract, we'll get negative 2. Can you think of that? One is positive, one is negative. I think we cannot think or look. Negative 4, what are the possible roots? Negative 2 and positive 2 for us to have negative 4. But then when you add this, you'll get 0. But our middle term here is negative 2. So it cannot be. Another factor is positive 4 and negative 1. But then solving this or adding this will give us positive 3. Or the other way around, if this is negative, this is positive, this will give us negative 3. So there's no chance for us to factor. Then let's use quadratic equation. And that is by applying the formula. So let's do that. Using the depressed equation, let us find the other roots by doing quadratic formula. Let me erase this first for me to write the quadratic formula and show the solution on how to get the other roots. Since we cannot factor this out, then we have to use quadratic formula. You learned that in the lower grades, I think in grade 9, that if you cannot factor the given, then you have to use quadratic formula, because factoring is not always the solution for you to get the roots. So remember the quadratic formula: x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Based on this, our A is equal to 1. It's the number beside the leading term. And then B is the middle term, so B here is negative 2, and C is the constant, which is negative 4. Now, let's replace this. X is equal to B, negative B. So that will be negative times negative 2 here. So this will become 2. Plus or minus b squared. Our b is negative 2. So negative 2 squared is 4. Minus 4 times a, which is 1, times c, which is negative 4. So 1 times negative 4 is negative 4. And then all over 2 times a, our a is 1, so this will become 2. Now, let's simplify this. Let me erase all this so that we can continue solving and find out the other factors, or the other roots that we are looking for. So, let me continue this. Copy 2 plus or minus 4 minus 4 times negative 4. Let's do this first. Negative 4 times negative 4 is 16. So this is 16. 16, 4 minus 16 is negative 12. Negative 12, square root of negative 12, then all over 2. So let's simplify this part. This will become positive 4 times negative 5. So that 4 times negative 5, negative 3. 4 times negative 3 is the same as negative 12. And then get the square root. This will give us 2 square root of negative 3. Square root of negative 3. So let's continue. So be patient. All we have to do is to be patient for us to solve this. Let me repeat how it happened. So I'm separating here square root of negative 12. And why square root of negative 12 again? It's here. 4 minus 4 times negative 4. So let's do this first. Negative 4 times negative 4 is positive 16. This one, positive 16. 4 minus 16 is negative 12. It's inside the square root. Let me copy this first. Square root of negative 12, we have to simplify this. It's the same as 4 times negative 3. And then we have square root for 4, which is 2. Positive negative 2, and then retain negative 3 inside. So this will become 2 plus minus 2 square root of negative 3 all over 2. This one. Ito yung 2 na yon. Then, let's continue simplifying this. Sorry for the messy computation. Math is really like this. You need to focus. Now, so let me rewrite it. Let me clear all here in the upper part. Anyway, you know already this formula. Don't forget this. This will help you a lot. So just to continue, here now, let me rewrite from here. So this will be 2 plus minus 2 square root of negative 3 all over 2. But take note, negative 3 is not yet acceptable because we have negative inside. So we have to find a way. Negative 3 is the same as negative 1 times 3. So that we can bring out square root of negative 1 is I, and then 3 will stay inside. So it's quite long. 2 over 2 here is 1 plus minus 2 divided by 2 is 1 also. 1, and then negative square root of negative 3 should be replaced by I square root of 3, or simply copy 1 times I is simply I square root of 3. So therefore, our final answer is this. Let me rewrite it. 1 plus minus I square root of 3. I square root of 3. So, this is complex number, one pair of complex numbers. So, in other words, we have two roots here. One is 1 plus I square root of 3, and the other is negative 1 minus I square root of 3. So, two roots here, two complex roots, plus one root here na negative 5. So, there are three roots in all, which is true because the exponent here is 3. I hope it's clear. It's quite long, but if you know the process, it's easy to find the other roots. Example number 4, find the roots again of the given polynomial. X to the fourth minus x cubed minus x squared minus x minus 2 is equal to 0. Let's apply the rule of sign. Let us determine how many positive roots and how many negative roots shall we get here. So let's have first the positive root. It's positive here, so positive to negative, 1 change, negative to negative, no change, negative to negative, no change again, negative to negative, no change again. So we are expecting one positive root. So one positive root. What about negative? Let me erase first for us to clearly see the changes here. For negative, let us remember that we need to change x to negative. So x here will become negative, and if x is negative, negative to the fourth power is positive. So still positive x to the fourth. X cubed, if x cubed is negative, it's negative. Then times negative, the original negative here, it will become positive x cubed. Next, x squared, if you make it negative, negative squared is positive, times negative here, it's negative x squared. Next, negative x, if you change x to negative, then negative times negative, it will become positive x. Then simply copy minus 2. Let's count now. Positive to positive, no change. Positive to negative, there is change. So there's one change here. Oh, it should be 1. Negative to positive, second change. Positive to negative, third change. So we are expecting 3 negative roots. Total roots in all, it's 4. Which is correct because the highest degree here is 4. Now, let's look for the roots. 1 positive root and 3 negative roots will be our guide only. This will help us to determine the number of roots. Let me erase so that we can have more space for us to solve and to look for the roots. Looking at the constant term, which is negative 2, and the leading coefficient, which is 1. So 1 is the leading coefficient, the constant term is negative 2. Then we can write the possible roots as positive, negative 1, positive, negative 2 only. Because this is 2, this is 1, divide the factors of this with the factor of 1, which is positive, negative 1, then these are the possible roots. So there are 4 here, but it doesn't mean that these are really the actual roots. Who knows, there will be complex roots. Since we are expecting 1 positive, let's try positive 1. So 1 as the divisor, then copy all this. 1, negative 1, 1, negative 1, negative 1, negative 1, negative 2. Again, 1, 2, 3, 4, 1, 2, 3, 4, then negative 2, 5. So let me solve this. Bring down 1. 1 times 1 is 1, negative 1 plus 1, 0. 0 times 1 is 0, negative 1 plus 0 is negative 1. Negative 1 times 1 is negative 1. This will be negative 2 times 2 times 1, negative. Negative 2. This will be negative 4. Let me review. Bring down 1. By the way, is it correct? Let me erase this to see if there's negative or none. It's really positive. So, bring down 1 here. 1 times 1 is 1. Negative 1 plus 1 is 0. 0 times 1 is 0. Negative 1 plus 0 is negative 1. Negative 1 times 1 is negative 1. Negative 1 plus negative 1, negative 2. Negative 2 times 1, negative 2. This is negative 4. It's not 0. Therefore, 1 is not a root. Let's try negative 1. So, let's erase and try now negative 1. Because positive 1 is not. We are expecting 3 negatives anyway. 3 negative roots. So let's have negative 1 and then copy all the coefficients. 1, negative 1, negative 1, negative 1, negative 2. Bring down 1. 1 times negative 1 is negative 1. Negative 1 plus negative 1 is negative 2. Negative 2 times negative 1, positive 2. Negative 1 plus 2 is positive 1. 1 times negative 1 is negative 1. Negative 2 times negative 1, positive 2. So finally, negative 1 is the root. So negative 1 is the root. So let us see, let's have the roots here. Next, let's try negative 2. So this time, let's have negative 2. Let's just change this to negative 2. And then delete all this. Let's retain the coefficients. Okay. So let's try negative 2. Bring down 1. 1 times negative 2 is negative 2. Negative 1 plus negative 2 is negative 3. Times negative 2, positive 6. Negative 1 plus 6 is 5. 5 times negative 2 is negative 10. Negative 1 times negative 10 is negative 11. Times negative 2 is positive 22. So it cannot be. Negative 2 is not accepted. Okay, how is this? We are expecting 3 negative. We've already used negative 1, which is not okay. Negative 1 is okay, and we've already tried negative 2, which is not okay. Now, there is one positive. Let's see positive 2. Let's see positive 2 if it is a root of the given polynomial, because we're done with positive 1 and positive 1 is not a root. So our last chance for positive is positive 2. So let's see if positive 2 is a root. Bring down 1. 1 times 2 is 2. Negative 1 plus 2 is 1. 1 times 2 is 2. Negative 1 plus 2 is 1. 1 times 2 is 2. Negative 1 plus 2 is 1. 1 times 2 is 2. So yes, it's a root. So 2. Again, we are expecting 4. So we have already 2 here. Negative 1 and positive 2. So we are expecting 2 more negatives. 2 more negatives. We're done with positive. So how to look for that negative? Now let's have the depressed equation. Or before that depressed equation, yes, let's have the depressed equation from here. This will become x cubed. Remember, this is 4 minus 1, so it becomes x cubed here, plus x squared plus x plus 1. Now, let us use this to come up with another depressed equation by dividing this by -1. So -1, since -1 is a root, we can divide this by -1 for us to come up with another depressed equation. So let me erase again this part. Anyway, we've already solved that 2 is a root. Now, we are looking for two more roots. Let me erase this also. Let me clear this part. Now, let's use this depressed equation for us to divide by -1. So, -1 and then 1, 1, 1 plus 1 here. So, how many ones? 1, 2, 3, 4. 1, 2, 3, 4. Bring down 1. 1 times -1 is -1. This will be 0 times -1. 0. 1 plus 0 is 1. 1 times -1 is -1. So 0. So -1 is really a root. Now, let's make this one as the depressed equation again. This will become x. To take note, this is 3, so this will become x squared. Ito yon, 1x squared plus 0x, no need to write, plus 0x and plus 1. Okay, so from here, let's equate to 0. This will give us the roots. So this will be x squared is equal to, transpose 1 to the right, it will become -1. Get the square root of both sides. This will be x is equal to, remember, -1. Square root of -1 is I. So positive -I. Okay, we're done. Let's see. Let's count. We have 4 now. But it doesn't jibe here that we have 3 negative and 1 positive. So, meaning to say, there's a possibility that there will be change once we know the actual roots. One possible for these 3 is that there is 1 negative and 2 complex, which happened here. We have 2 complex. These are the 2 complex numbers, positive I and negative I. Plus 1 negative here. So 1 negative here and 2 complex here is this one, this 3. And positive 2 here is the 1 positive root. But the important now is we're able to find all the 4 roots. And what are those 4 roots? So we have -1, positive 2, positive I, and negative I. So there are 4 roots in all. Consist of 2 real, so -1 and 2 are 2 real roots, and then positive I and negative I are the complex roots, which are conjugate. That's all about my examples and tutorial about finding the roots of the given polynomial using different theorems. Thank you for listening and watching my presentation. God bless and always study well.